Well, this epidemic equation may have seemed most complex and most difficult to us when we first saw it a moment ago. But with Dr. Reed's explanation of his happy people and his unhappy people, his cases, his susceptibles, becoming immune cases, it becomes very easy to see what the equation means. This mathematical equation is an epidemic theory. But before any scientist, any good scientist, will accept a theory, accept a mathematical equation, that theory must be proved. It must be proved conclusively. So it's taken into the laboratory, and in some way, a manner, a method is evolved to prove that theory, because if it's not right, someone else will disprove it. This theory that Dr. Reed has just been showing you was taken into the laboratory, and it was proved. And Dr. Reed has a very simple piece of apparatus here to show us how this equation, how this epidemic theory was proved in the laboratory.
Mathematical equations such as the one you've just seen need to be tested against experience. This one has been tried against a number of epidemics of measles in actual fact, epidemics of measles in several of the big cities in the world. The agreement between the observed cases of the epidemic and the theory is very good. However, to test this equation against observed epidemics is a slow process because epidemics occur only occasionally, and our records of these epidemics are not as good as we might wish. We therefore want some simple mechanism by which we can test the principles involved in this theory within the laboratory. For this purpose, we've designed a very simple machine that will allow us to consider the theory and apply it within the laboratory. We have here a wooden trough, which may be thought of as the city within which the people will live and move and circulate. That then is the city for a group of people that will be represented by simple beads. These white beads are susceptible individuals. They are the people who have not had the disease and may acquire the disease. The other class of people of interest is naturally the cases. These spotted beads represent the cases. They are the people who are ill. It is those individuals that will transfer the disease to these susceptible individuals. When the individual has had his case and is recovered, he then becomes an immune person, which will be represented by the purple bead. So that we'll have the three categories of people that are essential to a simple epidemic: the susceptibles, the cases, and the immune. We're now ready to try a simple epidemic with this machine. We may start an epidemic by assuming that we have 100 susceptible people. We'll put those 100 people together. We will introduce into that population one case. We'll have here a case of measles that we'll put in with that population. We must have some procedure for allowing chance contact to play, allowing that case to come into contact with the others. We shall accomplish that by making use of these slack beads, which are barriers, and you will see the effect of those as the epidemic is run. Now, to operate an epidemic, we have here 100 susceptible people. We have a case. They now start their process of living and moving within the city and mixing together according to chance. And in that chance mixing, that case will meet a certain number of susceptibles and will produce new cases. And we shall see the result of the epidemic. Here we have the epidemic with one case here, and it is in contact with 4 susceptibles. In contact with 4 susceptibles because it falls between the black balls. So that this one case, in circulating through the city, has encountered 4 susceptible people. The next step of the epidemic, of course, means that this case here now recovers from his disease, and he becomes an immune. And so we introduce an immune. This susceptible person that was in contact with him now becomes a case. And so with the other susceptible people. And so we replace these 3 susceptible people with 3 cases. We have a total of 4 susceptibles, have 4 cases now. Our population then stands. Our original case is an immune, and we have 4 new cases. Therefore, we have a remainder of 95 susceptibles. That would represent the first stage of the epidemic and the first transfer from the case to the susceptible. The next stage of transfer would be the events that would follow from having 4 cases now circulating in the population. And we can see the 4 cases circulate in the population, producing disease according to the individuals with whom they come in contact. Here we have our 4 cases. This one here has encountered 1 susceptible. Therefore, he produced 1 case. This case has encountered 1 susceptible. Therefore, has produced 1 case. This case here has encountered 5 susceptibles. Therefore, he's produced 5 cases. This one has encountered 1 and has produced 1. So that our 4 cases have produced 1, 5, 6, 7, 8 cases. And we can pass to the next stage of our epidemic by removing the 4 cases, since they are now cured, and putting in 4 immunes. We will remove the 8 susceptibles that acquired the disease in this and put in 8 cases. Thus, our population, a group of people, now stands as a population with 5 immunes in it, and with 8 cases, and with 87 susceptible people. The next stage of the epidemic will come from the movement of those 8 cases in that population. And we see that this case has met with 4 susceptibles, this with 3, that's 7 new cases, this with none, this with none, this with 5, that makes 12 new cases, this with 2, that's 14, this with 5 more, 19, 1 more is 20. So those 8 cases produce 20. So that our epidemic, starting with 1 case, that case transferred it to 4, the 4 transferred it to 8, the 8 transferred the disease to 20 people. We will find that as we continue this process, that the epidemic will die out eventually. The reason for its dying out is that the susceptibles will be used up. We will have burned away the fuel on which the epidemic lived, and so the epidemic will come to a natural stop. We will find also that we'll not use all of those susceptibles in the process. It will only be a part of the susceptibles that will be used up before the epidemic will stop in its natural course.